Next is the third question, and from this question, it asks the voltage across a parallel plate capacitor with area A and the separation D varies with time t as voltage V equal to AT squared where A is a constant. Find the displacement current between the plates. So as a reminder, the first equation is displacement current, which denoted as ID, will equal to the epsilon naught, which is a constant, and the change of the electric flux with respect to time. And we know that the electric flux is equal to the dot product of electric field and the surface area. And we can separate the surface area A out of the derivation because A is constant. So we get the differentiation of electric field with respect to time. And now let's see the second equation. We know that the electric field is equal to the derivative of voltage with respect to distance with a minus sign because electric field will flow from positive voltage to the negative higher voltage to lower voltage. And since the distance is constant because in the parallel plate capacitor the electric field is constant, so we know that the derivation is also constant, so we can change it to the delta V divided by distance d. And we can plug this into our first equation. We've got the following, and then we got V as AT squared, so we put in over here and find the derivation. And this is
Hello guys, today I'm gonna be talking about the first questions of my physics problem regarding the Maxwell equation or capacitor. And the first questions can be divided into 5 questions. The first question is A. A asks about the dip of E or dE over dt. And we know that current equal to 0.2 ampere and radius of plate of capacitor is 10 centimeter cm or 10 multiplied by 10 powers minus 2 meter, and d or the gap is equal to 4 multiplied by 10 or power minus 3 meter. And we know that capacitance equal to A epsilon naught over D. With capacitance, what we know, we're gonna get C equal to pi 10 minus 1 square multiplied by x.85 multiplies 10 power minus 12 over 4 millimeter. We're gonna get C equal to 6.95 multiplied by 10 powers 11 farad. And now we know that dE by dt equal to dV by dt divided by the gap. And we know that dV by dt is equal to dq by dt minus divided by c. And we know dq by dt equal to I. So what we have got is this equation to answer the first question or A question, and we just substitute by what we have known. We're gonna get I over 3D equal to 0.2 ampere over 6.95 multiplied by power 10 multiplied by 4 millimeter. And now we have got dE by dt, or this is the same, equal to 7.19 times 10 power 11 volts per minute second. And now let's talk about the second question, or second B. Question B. We want to find magnetic fields, and the equation related to magnetic field is ampere equal to mu naught epsilon naught d flux by dt, and we just substitute this by dE by dt multiplied by A, and now we know that this is equal to B multiplied by 2 pi r. Let's substitute by what we have known. We're gonna got PB equal to R epsilon naught mu naught over 2 dE by dt equal to 10 multiplied by minus power of 10 power minus 2 multiplied by 8.85 10 power minus 12 multiplied by 4 pi 10 power minus 7 over 2, and now we have got B equal to 2.0 10 power minus 2 Tesla. That's all for the fourth question. Hello guys, today I'm going to be talking about the 11 problems of my own physics homework, and now we have got discharging displacement current through a central circular area with R equal to R capital R over 2 give us I equal to 2 ampere. And now we want to find, if we take a look at the big R's or the capital R, the whole piece, what is the I of the capital R? Now we just use proportion. The area of the capital R over the area of a small r is equal to pi capital R square over pi little r square equal to pi capital R square over pi capital R over 2 the whole square. Now we know that the proportion is 4 times. So the area of the capital R 4 times bigger than the little r. Now we just multiply the current of little r by 4. We're gonna get the whole displacement current equal to 2 multiplied by 4 equal to 8 ampere. Because the electron pass through distributes pass through the plate equally, distribute equally. So we just use proportion of the area to determine how much current pass through the hole compared to arbitrary one. Thank you.
Hi, teacher Gang. Problem number 9. A parallel plate capacitor has a plate area of A equal to 0.250 meters square and a separation of 0.0100 meter. What must be the angular frequency omega for the voltage Vt equal to V0 sine omega t with V0 equal to 100 volts to produce maximum displacement induced current of 1 amp between the plate. So I summary the constant provided by the problem here, and we start calculation by using this equation id equal to constant time derivative of flux by dt. We will know also electric flux is electric E times area, but area is constant, so we pull it out, we made it dE by dt. We also that E equal to V by D. D is the displacement, and D, it is constant here. So we pull it out again, we made it dV by dt. We also know the equation of V. Vt equal to V0 sine Wt. So we find the first derivative of this value. We know that the first derivative of sine is cos, and we need to apply some chain rule to the Wt here, the omega t. So we got another omega. And finally, we got a general equation here. But if we need to apply to max induced current, the cos need to be highest value possible because it's max, right? So it should be 1. After that, we rearrange the variable again. We got what we need, or angular frequency equal to max I induced time d divided by constant area, and V0 is constant. We put the value in and we got the answer. 4.52 times 10 power 7 radius. Thank you.